Namaskar friends, welcome to session 24 in our course on operations management, and currently we are in the 5th week of our discussion on the course, and in every session I usually revise what we have covered in the previous sessions, and today also I will not deviate from the we can say tradition. I will again try to revise what we have already covered, but very briefly. We have seen the fundamental aspect, that is the scopes, objectives, functions, types of production systems in our week 1, in which we have covered the introduction to operations management. In week 2 we have covered product design and development. In week 3 we have covered sales forecasting. In week 4 we have covered plant location, and in week 5 we are covering plant layout or factory layout. Now we have entered into the factory. We are trying to do a locational analysis or trying to design and develop a layout of our factory. We are trying to see that where which facility must be created, must be raised, must be erected, so that we are able to meet our overall objective of 4 keywords. What are these 4 keywords? These 4 keywords are that we must be able to produce the product with desired quality, desired quantity, at appropriate time, at a competitive cost. So these are the 4 parameters: quality, quantity, time and cost. So we are trying to lay out our factory in such a way that our 4 targets are achieved, that we are able to produce a good quality product in right quantity with reasonable cost, competitive cost, and at the time it is required in the market. So the layout also affects the overall productivity of the organization. Within our discussion during this week, we have seen, if you remember, that why the layout is important, how do we define a layout, what are the different types of layouts. Then we have seen in the previous session what are the most important factors which govern the type of layout, and we have already now maybe physically moved inside the premises, and we are trying to see that how we can make a optimal layout which will help us to achieve our objectives of operations management. We have seen that there are factors which will govern our decision related to the selection of a particular type of layout. Today we are going to cover the material flow patterns within the layout, how the raw material will enter into the organization or the factory or the industry, and how it will traverse a path, and then how it will come out, how it is going to influence our layout. Then we will see what are the advantages of following a material flow pattern or following a particular type of material flow pattern, and what are the things which will be affected by the improper or maybe a non-judicious or maybe a faulty selection of a material flow pattern. So all these things we will try to cover in today's session. We may have a horizontal flow pattern or a horizontal material flow pattern, and we may have a vertical material flow pattern. So we will take examples of both and try to understand that once we are inside the factory, we have to see that how the material will move inside the factory or the plant, so that our overall objective is met and we can ensure a proper flow of the material, proper sequence of operations on the material, and finally we get our desired good quality output, and our good quality output is our product that we are producing. So let us quickly have a brief introduction of material flow pattern. So first of all we need to understand what do we mean by flow pattern. So as I have already told, our focus is on material flow pattern. So material, all of you know. How do we define flow pattern? Let us read it. Flow pattern means the system to be adopted for the movement of raw materials from beginning and up to the end of manufacturing. So what is the end of manufacturing? That is the final product has been produced. So the flow pattern means the system to be adopted for the movement of raw materials from the entry to the exit, from the maybe beginning to the ending. So it is the flow of raw materials within the organization, within the factory, within the plant. The overall objective of the flow pattern is to plan for the economical movement of the raw materials throughout the plant. So the word economical is coming into picture. So we have to ensure that there is no unnecessary movement of the material inside the plant. We need to minimize the movement of material. We need to economize the movement of material inside the plant. Many a time you will see that you go to a plant and you will, if you stay there for some time and observe the movement of material, even using common sense, you will try to find out that yes, when the plant was set up, this may have been the most optimal design or the layout of the machines, but with passage of time we have seen that revision of layout is also done, and in the revised layout you will see that there is unnecessary movement of materials sometime, which needs to be checked, which needs to be economized, which needs to be optimized in order to achieve our overall objective of high quality, cost effective manufacturing. So basically material flow pattern is the pattern or the flow that is being followed during the manufacturing process specifically for the materials. So we will see that how the raw material enters into the factory, what sequence of operations are done on the material, and how it goes out from the factory. So that is the basic meaning of the layout of the material flow pattern. Now why it is important? Because it affects the overall productivity of the organization. It affects the material handling cost. It affects the amount of work in process. Now work in process or WIP is a new term that has come in our course on operations management. We are using this for the first time. So work in process is nothing but the materials, the sub-assemblies, the sub-parts, components that are in the process of production. For example, if you remember in our line type of layout, we have seen that there are work centers, work center 1, work center 2, work center 3, and there are 3 components A, B and C that are being manufactured at different locations or different points and are coming to these 3 work centers, are getting assembled to make a product X. Now these 3 parts will constitute the work in process, and finally they are getting assembled and are being a part of the final product. So the amount of work in process is definitely influenced by the type of flow line or flow pattern that we have chosen within our organization or within our plant layout. Also, the flow pattern will influence the capital and the space tied up by the work in process. Surely it is going to influence the capital and the space tied up, because sometimes it may so happen that our work in process is getting piled up and we require space to keep that work in process at a particular location, and it will definitely affect our flow line. And the flow pattern will also affect, means they will affect vice versa. For example, we are having huge work in process piled up at a particular location, we would like to bypass that location and try to follow a different flow pattern. On the contrary, that suppose we have selected a particular flow pattern and there is a very slow machine in between, what will happen? The work in process will pile up at that location. So the selection of a flow pattern will also influence the work in process or piling up of the work in process. On the contrary, if the work in process has piled up because of one reason or the other, it may influence our dynamic change towards a new flow pattern in order to overcome that situation. So they are affecting each other. Length of the total production line is also influenced. We will see that we have a I type of material flow, we will have a U type, we have a S type of material flow, that we will try to understand with the help of diagram. But the flow pattern will certainly influence the length of our total production line. Now the flow pattern affects the following: the rate of the performance and coordination of operations. It also influences the amount of physical and mental strain on the operators, as well as supervision and control mechanisms. So all points can be explained with the help of certain examples, because suppose we say supervision and control mechanism. So if we have a I type of flow pattern, the raw material is entering from one end and it is getting converted in a linear fashion, and at the other end the product is going out. So the supervisory control may be not very effective, because maybe we may require, the length is large, we may require maybe 2 or 3 supervisors to keep a check on maybe 8 to 10 operations each. But suppose we have a U type of pattern, we can have a centrally located supervisor who can control both the ends of U. So the type of flow pattern that we choose, it will affect the type of supervision and control that we can manage within our organization. Similarly, the amount of physical and mental strain also is affected by the flow pattern. So the flow pattern will not only affect the materials, it will affect the people also, it will affect the procedures also. So we have to understand the importance of flow patterns. So we can see that the rate of performance and coordination of operations is also affected by the flow pattern. So with these points, the overall objective of discussing these points is that we must know, we must be able to highlight, we must be able to understand the importance of the material flow patterns. As otherwise, usually as students we feel that how this is going to affect. It is a simple thing that the raw material is coming, it is following a particular sequence of operations, and the material is getting converted into a final product and it is going out. No, it has got certain importance, and the importance lies in the overall productivity of the organization. Suppose it is whatever examples we have taken, we have tried to display or portray a positive picture, we have tried to take positive examples only. So let us take, if you select a wrong flow pattern, what can happen? Your supervision is not proper, the quality of work that you are producing is not proper, your work in process has piled up. So we can see that there can be so many issues and challenges if we choose a wrong type of flow pattern. So it is also important. One thing that is also covered earlier in earlier discussion also is the effective and efficient use of the space. Suppose we have some area or some floor space available with us, we have to see that how we should locate our machines, what should be the flow pattern of the material flow inside that floor or inside the organization in that floor space, so that the optimal utilization of the space is taking place. Many a time we will see that a lot of space is being wasted and not utilized properly. So the flow patterns, if we address this point in a emphatic manner, we will definitely be able to save a lot of space or a floor area for our organization. So just I want to again reiterate the importance of flow lines, and I will read these points again for you. So the flow patterns will definitely affect the material handling cost, amount of work in process, capital and space tied up by the work in process, length of the total production line, the rate of the performance and coordination of operations, amount of physical and mental strain on the operators, supervision and the control mechanisms. So all these factors, all these we can say points that have been written on these two slides are being affected directly or indirectly by the selection of the flow pattern. Now, what are the factors that govern the flow pattern that we are going to choose? One can be external transport facilities. Now, one example can be a thermal power plant. In thermal power plant, we require coal as the raw material. Coal will burn and then it will be used as a fuel for the boilers, and then we'll produce steam, and then we'll produce power from that steam. So, basically we have a raw material that has to reach the plant. Many times you will see in thermal power plant there will be a dedicated railway line which will bring the coal in the wagons. So, we have to see that where we have that facility where the wagons can come, the material can be unloaded from those wagons, and then this can be brought to the place where it has to be used. So, that distance has to be optimized or minimized, and from there we see that the raw material is reaching at this point. What can be the material flow line in order to optimize the overall operations? For example, there is a very big sheets of material or very bulky raw material which is coming to the organization, where it will be unloaded. Once it is unloaded, how to ensure that from there it travels the minimum possible path inside the factory, so that the overall objective of converting that raw material into the product is achieved, but the movement of the material is minimized. So, the external transport facilities will definitely affect. We will see with the help of diagrams also that where the material is getting offloaded is important and will help us to select our flow pattern accordingly. Then the number of products to be handled is also important. If you see, specifically in case of assembly type of lines or assembly operations, we will have a straight line or I type of line or the flow pattern, because the number of products to be produced is large. So, we will see that the raw material should come from one end and the final product should go out from the other end. Suppose some of you may be wondering that when the operations have to be done in one line only, why can't we use a U type of layout there, because the sequence remains the same. Absolutely true, but the explanation that comes to my mind is that when we are doing a large scale production, our raw material will also be huge and the final product that we are making will also be in huge numbers. So, if we start from one end and follow a particular sequence of operations and the product also comes out, as in the case of U type of flow pattern that we will see that in the diagram, the U type of flow pattern. So, the final product is coming out at the same end only. Suppose again I am saying this is the U, so the raw material enters from one side and it is following a particular sequence of operations and it comes out from the same side. In a horizontal, U can be like this. So, it is entering from here raw material, 1 operation, 2 operation, 3 operation, 5 operation, then sequence of operations and finally final product. So, here we have huge pile up of the raw material because the process is continuous. We require to feed the raw material continuously and our final product is also coming out continuously. So, suppose both are in this location or this space requirement will be huge. So, we can do one thing, that we can input the raw material from one end and the product can come out from the other end. So, on both ends we can have the space. On one end we can have space for raw material, on other hand we can have a space for the finished product. So, maybe depending upon the number of products to be handled, we have to choose the type of flow pattern or the material flow pattern. Number of operations on each product is also important, that on each product what is the total number of operations that we are performing. Number of units to be processed, I think number of products and units, I think this is one and the same thing. Number of sub-assemblies made up ahead of assembly line, so that is also very important. The number of sub-assemblies, as we have seen in our example of a line type of layout in this week only, that there are workstation 1, workstation 2, workstation 3. Then there are 3 sub assemblies, maybe A, B and C, which are coming to these workstations in a line. The workstations are arranged in a line and these sub assemblies are getting assembled with a final product, or getting assembled into a final product which is moving out from the factory layout. So how many such sub assemblies are there? What is the size of the sub assemblies? How many parts are there in these sub assemblies? All these factors will influence our selection of a material flow pattern. So we will see that what are the number of sub assemblies made up ahead of the assembly line. So our material flow pattern, we are only talking about the final assembly lines only. So we have to see that how many sub assembly lines coming into the main assembly line. For example, we may take example of a river. So our large river is, or our main river is our material flow pattern. There can be number of tributaries that are coming at different points and are getting merged with the main river. Similarly, our flow pattern is analogous to the main river, and the tributaries are analogous to the sub assemblies which are coming and getting merged with the main assembly line. So size and shape of the available land, this is the most important parameters that is coming to my mind, because space is the major limitation for setting up any factory. So we are hard pressed, we are constrained with space, so we have to ensure the optimal utilization of space. So if we have specific area available with us, we will see that which is the most possible or which is the most optimal type of flow pattern that we must follow. Necessary flow between the work areas, that also will affect the flow pattern, that whatever is the necessary flow, necessary may be there may be times when there is we try to figure out that what is unnecessary movement, what is necessary movement. So once we classify these two things, we can very easily ensure that we have to plan only for the necessary flow between the different work areas. So we have seen that how the flow pattern is going to affect our overall manufacturing or overall production, and what are the factors that govern the flow patterns. So these may be more theoretical. So more from practical point of view, now let us see what are the different types of flow patterns. So we have a horizontal flow line and we have a vertical flow line. So we will try to take examples of each one of these and try to understand that which type of flow pattern will be more successful or more applicable. Horizontal flow lines, you can see there are so many examples. We can have a I flow or line flow, we can have a L flow, U flow, S flow, O flow. So we can see that different types of space available with us will force us to choose any one of these flow lines or any one of these flow patterns. So let us see what are the maybe salient characteristics. Majorly we will see in flow line, the raw material will enter into the flow line and then it will follow a particular sequence and then it will come out as a final product. So the overall maybe the picture will remain same, but the physical location of the facilities or machines or equipment will be in this particular format only or in this particular shape only. So I means, as all of us know what is I. So I is maybe a one straight line. So the location of various machines will be in a straight line and the material will move in this line, and during this movement it will get converted into the final product. So we may have a I type of arrangement of machines, we can have a L shape of arrangement of machines, we can have a U shape of arrangement of machines and other facilities. So this is basically I, L, U, O are the shapes in which, or maybe the location in which the various facilities are arranged within the layout. In previous session we have seen different types of layout. For example, in line type of layout we have to follow a particular sequence of operations. So that can be maybe one particular layout which is specially, we can say, focused for these type of flow lines, because all machines are arranged in a particular sequence and in a particular shape, and the product moves and undergoes the various operations and finally comes out as a final or the raw material goes into the different operations and comes out as a final product. So we will see how these flow lines look like. So I flow, very simple example on your screen, straight line. It is the simplest form of flow line. In this, the materials are fed at one end and components leave the line at the other end. I flow is preferred for building automobile industries or for developing automobile industries, as I have already taken an example that I flow line is most suitable for assembly lines. Then we can have a U flow on your screen. In this, both feeding means the input of raw materials, and output, that is the final product. So in this, both feeding or raw materials and output take place at the same end. Here we can see a U type, and there is an arrow which points out at the movement of the raw material, and this arrow points out at the final product that has been made or manufactured. So in comparison to I, this method is easier for supervision, because in between we can have, this is the arrangement of machines. So you can have supervision in between, and one person can keep a check on both sides. So that can be ease of supervision and control mechanism. And this type can be adopted in electric motors, manufacturing of electric motors. This is S flow and combination of S flows here. So if the production line is so long that zigzagging on the plant floor is necessary, then S flow is adopted. Now this types provide efficient utilization of space and is compact enough to allow the effective supervision. So we will see wherever we are cramped for space, we will try to go for a S type of layout, but with a condition that we have to ensure proper circulation space also. The workers or the working personnel who are working may not feel too cramped for space. So all those parameters have also to be taken into account, and then we can arrange our machines and equipment in S pattern so that the material moves in S pattern and finally gets converted into the final product. So we have seen I type, we have seen U type, we have seen S type. Combination of S also can be used. Then O flow is another type of flow pattern. This type is used where processes or operations are performed on a rotary table or a rotary handling system. So this can be maybe one example where again we want to emphasize on effective utilization of space, better supervision and control. So we can also, the type of land or the type of floor space available with us, we can even go for O type of arrangement of machines. When the component leaves the O line, a complete set of processes or operations have already been performed. O flow can be adopted by industries manufacturing electrical bulbs. So it is not a specific for electric bulbs only, it can be used for different types or different variety of products, but the arrangement of the facilities will be in the shape of a O. Then maybe all these flow lines that we have covered, starting from I, then U, and then we have seen S, then we have seen O, are coming under the horizontal movement of the materials only, that we have one floor, and on that floor the sequence of machines is arranged either in the shape of I or in the shape of S or in the shape of U. But then I have, as I have already told you, that land is a most precious commodity. Instead of using X and Y coordinates, many companies usually go for the Z coordinate also. They do not use only the floor space, they also try to raise the different floors and make use of the Z coordinate also. So we can have a vertical flow lines also, and different types of vertical flow lines are there. I'll read it for you. Processing downward or upward, centralized or decentralized elevation, unidirectional or retractional flow, vertical or inclined flow, single or multi-flow, and then flow between the different buildings also. Because last one, let me explain, each one can be explained in detail, but this is just to give you an idea that the material flow, usually we take it in a horizontal direction also only, but many times in many industries you will have a material flow in the vertical direction across the various floors of the organization or the factory or the building. So the last one, like flow between buildings. Suppose the company has two buildings, so the flow can be either at the top you can have a bridge in which the material can flow from one building to the other building on the top floor, or the material can be at the ground, so you bring the material down and at the ground floor only you are doing the flow of material from one building to the other building. Maybe one explanation of flow between buildings. So one examples, with the help of photographs you can see, or with the help of picture, processing upward or downward. So these are the different flows. This is a vertical direction. So in vertical direction we can have upward or downward movement, we can have centralized or decentralized elevation, unidirectional or redirectional. We can see unidirectional, the material is entering here, moving in a specific direction, top floor, and then maybe moving downwards and then finally being produced here. But here we see there is no, the material is entering, then it is moving here, again moving here, it is again retracting, again going back to the top and then coming down. So we can have a unidirectional or retractional flow. Then we can have vertical or inclined flow. Very easily you can see the material is moving vertically, whereas here it is moving in an inclined fashion. Single or multi flow, material is entering here, it is being subjected to different operations in a sequence, and then finally it is getting out, and then there is multi-flow also possible. So we can see that the material may not flow on horizontal floor only, material may flow in the vertical direction also across the various floors of the building of an organization. So with this we come to the end of today's session. I think we have tried and we have been able to understand that within a factory layout the material takes a particular flow line, and we have to select the flow of material, we have to arrange our machines and equipment and other facilities in a specific flow line only in order to ensure the effective and efficient utilization of the various resources that we are using for converting our raw material into the final product. So with this I conclude the today's session, and in next session we will discuss our final aspects related to the topic of factory layout. Thank you.